Yeah.
I think, right? So you can just record this, right?
Yeah.
Okay, perfect.
Yeah,
And then
no worries.
just record. Nice.
Cool.
And then just to put the... Yep. So you can start?
Yeah.
Okay. So is the camera already running or?
Yes, it is.
Okay. So then, welcome to this small lecture of mine. I'm Eric. This is my name, this is my intro name, so if you have any questions after this lecture, you can either ask them in person, I speak German and English, and otherwise you can just message me on Slack and I'll be always happy to answer your questions there. Okay, before we start, who has already had some experience with programming before? Like, is there anybody who has experience with maybe C or other languages like Java? Something doesn't have to be much. Okay, that's good. Who doesn't have any experience whatsoever? Okay, then we'll take things from the bottom. Okay, when you started applying to the 42, what was your goal? What was your idea about programming? Do you already have like a concept in mind on what you want to do with your new skill, like what you want to code, or anything that inspired you to become a student at the 42 here? Like, just think about that, keep that in your mind, and the way we're going to take things is we're going to just start from the bottom, from the C language. We start from the mentality behind coding and slowly work our way towards the goal that you have in mind, which often is, well, I want to write my own app, or I want to write my own whatever. A bit of background information about me. I started out about 10 years ago. I taught myself programming, which was a pretty hard and complicated way to do things, so I wouldn't recommend that. And this is also why I'm quite happy and proud that we have the 42, because this is exactly the place where you can both learn it by yourself or ask other friendly people who are going to explain things to you. And this is also my goal here, to give you a few bits and pieces of inspiration on how to actually start out with it, because most of you don't have any experience whatsoever. Right, so you might have already noticed that we are coding in the language C, which is a pretty old language. And what's special about C is this language is pretty close to the metal, or close to the hardware. So people, when they say close to the hardware, what do they mean? Well, it's often that what you write is what the computer does. The computer doesn't hide any things from you. So if you want something done, you have to write it yourself. There are other more complicated programming languages that take some important things away from you, that make it easier to write code. C is not like that. If you make an error in C, the system is going to crash. If you make any mistakes, the system will be quite unforgiving, and therefore you really have to know your stuff. And if you have any errors in your code, which happens even to the best of us, always keep in mind that C is a language that is pretty hard to master. It's your first programming language mostly, so don't be afraid if something doesn't work out from the beginning. C is a pretty hard language to start. Okay, so just as a quick reminder, because you might or might not have already forgotten about it, when you write a C program, you often put it in a specific file on your computer. So you have, for example, a .c file on your system, and you want to write a program, you often put your source code into that C file. So for example, you have your hashtag include, and all of the other stuff that's important, and you have this int main, and all of the other funny stuff. All of this goes into your C file. So please raise your hand if you've already seen this or know what this does. That's good, because if you don't, then I'm really wondering how you managed to get through the scene. Okay, so if I were to ask you, don't worry, I'm not going to, but if I were to ask, which one of you could explain what a C file basically is? Like what it contains, and maybe what's the difference between a .c file and the executable? Like the executable. My handwriting is not that good, so if you can't read something, please just raise your hand and tell me. Okay, which one of you who knows what the difference between a .c and a .exe file is? Okay, quick recap for the others. Your C file is basically the place where you put your code. The .exe file, or whatever file you design it as the binary file for your computer to run. You can name it whatever you want. This file is basically just for the computer to read. So when you write code, there's always a few stages involved. First of all, you're going to write your .c file. This is basically the first part. Then we have a second part, which is actually converting your C file into a .exe file, or whatever extension you desire, so any kind of file that's executable. And then the third part is running the file and mostly getting an error. This is basically what happens when you write code. So it's always the same things. You code, you compile it or put it into some executable format, then you run it. You most likely will get a crash. It's really rare that a program runs on its first try. And then you just get back coding. And this is basically the process that you might have already encountered in your programming days in the PC. For the first step, I think you all know you use an editor for that, maybe VS Code or something else, which is probably the basic environment that we all have. The second part consists of two things, which is the make file, that some people might or might not have some difficulties with. So I'm going to do a whole lecture on make files maybe later on. The second part of step number 2 is the compiler. The compiler is actually the heart of the programming language. So when you have your .c file, you put it into the compiler, and the compiler will then generate the binary file for you. So again, this binary file consists of these famous zeros and ones that your computer understands. Your .c file cannot be understood by the computer. The cc command, which is the compiler, basically is the necessary thing in order to run your code. Okay, and third thing, once you have your executable, it's not just happy running there. In most cases, you'll have to test your program before you submit the solution for your exercise. Testing is really important, and I'm also going to tell you a bit more about that later on. So these are the 3 basic steps, but since we're all computer programmers or aspiring computer programmers, there's something more to it. And because computers always start counting from 0, we also have a step number 0 that comes before 1, which is thinking. This is a step many people tend to forget, and you're not to blame for that if you forget about step number 0 and immediately start with the code. So before the code, there's actually some kind of concept that you must or should have, what your program should do, what the requirements are that you make sure you understood the exercise. And this is something that many people just tend to forget. So when you have the feeling that you understand C and just start typing into your editor, compiling and running, in most cases, in step number 3, you're going to get a problem, because just starting to type often means that you didn't think about the problem. So it might work for a short bit of time, but in the long run, doing some thinking before you type is often better than hours and hours of romantic debugging in the shine of the computer monitor at night. So yeah, that's basically the process that you are going to go through over and over again for every project, but also inside of a project many, many times. Any questions right now? Or to be more precise, did you all understand this? Because this is really important. Okay, honest question. Which one of you have missed step number 0 at some point? I would be surprised if you haven't, because like whenever you encounter a bug, whenever you encounter a segmentation fault, if you know what that is, like some kind of error, it's always going to be here. And there's a pretty neat quote that I once heard. You don't just write code for the computer to understand. When you write code, it's often about having people understand what your program does. The computer can interpret numbers, but why do we have programming languages? Programming languages are there to make it easier to write programs, but also to make it easier to read programs that other people wrote. So there's a really important part that I'm going to teach you about, which is making your program simple to read, simple to write, and simple to understand. Because if you don't manage to get the first part correct, then you don't even stand a chance at getting the third part correct. And if you don't get that one correct, celebrating 100 points in your exercise is going to be a pretty hard task and more luck than anything else. Okay, right. Let's do a quick vote. So who wants to learn more about step number 0? And who's more interested in step number 1, the C language? So this is what I'm going to concentrate on today. The C language is part number 1, and step number 0 is the thinking. So just out of curiosity, who's interested more in the C language? So who already thinks that they know how to reason about programs, and who's interested in learning C first? Good, very good. Because otherwise I would have told you that without the proper mindset for each programming language, writing the language itself doesn't really make a lot of sense. You can Google on GitHub some code that you can read and understand, but without this base, you're pretty much lost later on. And this is what I had to learn the hard way when I was getting into programming. So I'm going to teach you a few lessons that I did back in the day, and or that I learned the hard way back in the day. And once we have that settled, I think you're going to have a pretty neat start into programming in general without doing all of the minor mistakes. Okay, let's get to it. Is it okay if I clear off the board, or does somebody want to take notes? Good. Okay, so the proper mindset behind coding. I think the first and most important part is that whenever you read or write a piece of code, whenever you try to understand or tackle a task, what's going to happen is this. You're going to have a real big question mark in your head, and this is not going to go away. So even the most experienced programmers are used to the fact that they don't understand the code they're looking at. And this is happening quite often. So whenever you're asking yourself, what does this piece of code do? What should I write here? What should I type? Or what's even the exercise? It's normal. Don't worry about it. Like, this is more or less the 42 motto here. Don't worry, things are going to be okay, and we really mean it. Whenever you have a question mark, don't worry too much about it. Everybody does at some point. And in the end, things are going to make sense, more or less. There are programs that are not that easy to understand, but generally speaking, this question mark will go away after some trying. It's normal to struggle, and whenever you see errors or your program will just not behave, don't worry, question marks are alright. Okay. First thing, errors are good. So whenever you see your compiler telling you that you forgot something, and maybe, which is the most common one, you forget about this semicolon. You might have had this bug before, that you just cannot find the error or the source of the error, but in the end you just wrote a function that didn't have the semicolon at the end, and the compiler just slapped you in the face and told you that this is an error, and things shouldn't be that way. Well, the compiler is very strict, so it expects a very concise and a very specifically defined language. If you forget something, the error is on you. But don't worry, again, errors are good. Because this is the compiler telling you that you wrote a piece of code that, well, doesn't really make sense. And whenever you see the compiler telling you that your code doesn't make sense, then basically you've missed something in step 0, or you just forgot to type one character. It depends. Okay, second of all, keep things simple. This is also something I see quite often. People are going to write functions like int main, put something in here, and then put a huge block that looks like this in the editor. So very small code comparatively, but very long. And what they're going to say is, don't worry, I'll fix things later on. No. This is not going to happen. in the end, what's going to happen is you insert a line here to fix an error that happened here, then you add a line here, remove a line there, and in the end you have a whole bunch of code that just grew like a piece of cancer, and you don't really understand what it does, why it does it, and all of these minor fixes that you inserted are basically going to fight and bite each other. And in the end, you're going to be the one who suffers from it. So keeping things simple is often easier than just fixing one thing here as it appears and then fixing another thing there. This is often, like code like this, is often, not always, but often an indicator that you didn't think about what you were doing. Which is okay. Again, errors are good, and there's no shame in just deleting all of that, which is what I'm going to do now, and just rewriting things. Like, the best code is code that can be rewritten quickly, which means the code should look more like this. A few lines of code, if possible, less than these 25 lines that we have by the norm, and then do a lot of other function calls in here, for example like this, or like that. Like foo and bar are usually what programmers use if they are too lazy to think of names. So, doing a lot of function calls and writing many functions that are small is often a good thing to do, because when you want to change things, you don't have to wipe out your entire big piece of code that you wrote in 20 days, but you only have to wipe out a small piece of code that you wrote in maybe half an hour or maybe a few minutes. So in the end, if you keep things simple, you can change things. So changing things is going to get simple too. Again, you might be tempted, because there's some bug, or you want to add something, to just add something here, and then something in here. If that happens, if you notice yourself doing this, oh, I just want to add something here. Once, it's okay, twice also. But if this makes your function bigger and bigger, it's an indicator that you should maybe clear the entire thing and start at least this function from scratch. This doesn't have to mean that you have to throw away your entire program, but at least this function can just be rewritten and quickly because it's small. Once you get over the limit, things are going to be too complicated. Alright? Good. Again, errors are good, keep things simple, but there's also another thing, which is know the language and understand what you are doing, which is easier said than done, because when you start out without any programming experience, then of course knowing the language is hard, and also understanding what you're doing is hard. So personally, I'd say when you code, it's 80% thinking and only 20% coding. So when you see people write code, you often see them in this part. Like, this is what you see people usually in. But most of the work actually gets done in the 80% of the time before. If you don't understand what you're writing, if you cannot explain that to another person, if they just came by and asked you, what are you writing? And if you can't explain it within a few seconds, then you're already basically lost inside of this function, which is not a good thing. So this is always an indicator, and you might have to stop yourself when you notice that you're getting into this. You might have to just shut down the computer, or not shut it down here, I don't think we're allowed to do that, but just turn the screen off, or close your eyes, step a few meters aside, go to a whiteboard and start drawing. Just doodling things, doodling some kind of structs or some kind of functions, how they should interact with each other. You're going to learn how to do that soon. And once you do this, or maybe just take a walk or something else, once you do this, this problem basically goes away, and you're going to go there again and then start wondering, oh, what did I do there? Okay, let's just start again, I now have an idea. And then things are going to work out better than if you just sit there for hours and hours trying to hack into your keyboard, and in the end there's still some kind of memory leak or crash going on. So the best way to start coding is actually to experiment, which is awesome, which is also the next rule, by the way. to experiment, but also if you notice that you are stuck, and this might even be if you start to zone out. If you see, okay, I'm just doing something here, I don't understand what it does, this is often an indicator that you should shut down the computer or log out. Just take your time, 5 minutes, maybe 1 minute, depending on how much thinking you have to do, and then take your time. This might reward you in the long run, when it comes to time, more than if you just spend hours and hours just typing into the keyboard. Okay? Makes sense? Okay. Sometimes you can't avoid it, by the way. Sometimes you really do have to type in thousands of lines at once, or maybe hundreds of lines. Thousands are pretty rare. But once you notice that you are stuck at one problem and don't know what to do, step back, do whatever you want, and then approach the problem. Maybe talk to other people. The 42 is all about peer learning, so just take your time, talk to the others, ask them, and nobody's going to blame you. Again, errors are good. If you don't know what to do, ask others. They're in the same position, they are all, like everybody starts out with a big question mark. So don't be worried about asking people. This is a very supportive community here, and I think nobody's going to judge you or blame you for some kind of errors. In the end, I think if everybody learns from this, actually sometimes the people who tell you how to do things will learn something new from this too. So in the end, everybody's going to benefit from questions. So take your time, ask questions. And the last thing that's important, experiment. If you only follow the exercise and start typing in all of the stuff that you've thought about, you're not going to go anywhere. You're going to answer one exercise, maybe two, maybe three, but you're not going to get the broader picture. And what I think is really important is not only knowing what you're doing, knowing the language, but also knowing what you cannot do with this language, or where things get hard. And this only happens when you experiment with your code. So when you see some kind of function that takes a number, for example, there might be the square root function that you might have encountered, maybe not, it's not that important that you have encountered it in a PC, but the square root function basically calculates the square root of a number. So you can say the square root of 4, it will give you 2. And you can then say, okay, what happens if I plug in -2 in here? Because this will give you, mathematically speaking, a complex number. Don't worry, I'm not going to go too much into math here, but just as an example, just plug in some random values into functions and look how they behave. What they do, what they don't do, if something crashes, why it crashes. For example, if you have already used malloc before, what happens when you malloc 0? What happens if you malloc 10 and then free the pointer and free it again? So you might not be too familiar with this, and this is okay. Again, question mark, that's alright. But if you know what this does, and if you haven't tried it out, feel free to do it. Try it on different platforms, try it wherever you can. Like, be creative, experiment with your code. This is going to give you a lot more insight than the exercises themselves will ever do. This is basically the roadmap that I can give you. So these are the most important things. The rest is actually just finding your own way in learning stuff. So I can't tell you how to learn things, there are other people who are more skilled in this, but from the coding side, this is actually the part where it really gets important. Okay. What I'm now going to do is I'm now going to switch over to the C language itself and how it's connected to the computer. So when you write C, what are you actually writing? Because this is also something that's really important to understand, and it's also important to be aware that every programming language that you have is basically just an abstraction. It doesn't really exist on the machine. It's a mechanism made by people to make programming more easy, but in the end, all the computer does is the same thing, and even the C language boils down to all of these basic principles. So I'm going to introduce you to the basic principles, and how the C language connects to it we'll do maybe later on, or maybe in the next lecture. Okay, I hope you're all fine if I clear this off too. So we do have a recording, I hope so at least, if the camera works. And,
we do.
Yeah, I think things will appear on YouTube or I don't know where, but somewhere they will, and I'll inform you where they are. Okay. So let's get to the next part, which is basically, I like again, don't be too afraid of this. Even if there's a lot of information going on, don't worry. It's normal if you don't know what to do with this information from the beginning. Just look at it, experiment with the code, try to build connections, and then at some point things are just going to snap and you are going to understand it. It's a promise, so it actually will make sense. Okay, so when you have a computer, which is the kind of machine that we are going to program. So this is our happy friend, the friendly computer, and it's a pretty stupid thing. It doesn't know anything from the beginning. So when it's unplugged, what's happening is there's nothing in there. It's a pretty stupid box that just gathers some dust, and there's not much you can do with the computer without power. So you can maybe put some kind of plants on top of it, and maybe like enjoy it as some kind of yeah. I don't know what you can do with it, but without power, a computer is pretty useless. So when you press this button, the computer starts doing something, and of course only if it's plugged in, which it is in this case. And whenever you switch on your friendly little happy computer here, with a keyboard and mouse, I'm not a good artist, but I hope you see what I'm trying to draw. Whenever you switch on your computer, it's starting to do something. For example, it might print some kind of logo here, maybe an apple or a banana, I don't know. So your computer will do something. And in the end, what this computer does is all programmed by people. So a computer is made by people for the people, which is a pretty weird thing to say, but in the end it's true. All of the code that's running in here was written by people at some point. And as you know, people always make mistakes, and people are not perfect, so things are going to be weird at some point. The computer might not do the things you intended to do. Sometimes you press a button and it was not the button you intended. Sometimes you enter a command and it accidentally wipes your hard disk, so keep backups. All of this will happen, so a computer is a pretty weird kind of machine. And your task is to write a bunch of instructions so that it does what you want. Which is okay, but it's also a pretty heavy task, both mentally and maybe even physically if you have to stay up late at night. Okay, so we write our code in C, but there are many programming languages out there. So C is not the only one, and the computer will definitely not understand C. If you tell it, well, run some C code for me, it's not going to understand it. It understands only zeros and ones. So the saying is true, the computer only understands zeros and ones. Even numbers like our 42 is essentially just a bunch of zeros and ones packed together in the memory of the computer. Without the memory, the computer won't do anything because it can't remember what it does at the moment. So it's like having amnesia. So memory is an important thing. The other important thing is the CPU, which is your computer core, maybe an Intel i5, i3, or maybe an ARM or AMD, whatever. I think you know the models. If you don't, it's not that important. The CPU is the important thing. Memory and CPU work closely together, and when you write code, you often have to think about what your memory contains and what your CPU does at any point. And if you write code and somebody comes along and asks you, what does your code do to the memory and to the CPU, you should be able to give at least a rough answer on what's actually happening in the machine. If you don't, then this is always an indicator that you have missed step 0, which again was that you have to think first what your code actually does to this machine. Because as I said, it's a machine made by humans, and therefore, if you do things wrong, the mistakes done by other people are just going to be around. Okay. Now, memory and CPU are what you have. I'm just going to give you a small overview. Like, when you plug in a piece of memory, like you have your DDR3, or maybe even your DDR4 RAM, which is often something like 8 gigabytes, or maybe 16, or maybe 4 if you